Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper TG Set 2024, Telangana Set exam held in 2024. In this video, we discuss the solution of a problem from the section Linear Algebra, and it is placed at serial number 65 in the above question paper. And the question is related to the Jordan Canonical Form, which is a very important subsection, and it is very important to talk about Jordan Canonical Forms. And if you are not having enough knowledge about Jordan Canonical Forms, please read and prepare a good notes on it. And this question is suitable for all these examinations. Right. The given question is the Jordan canonical form of the matrix A. It is a 4 by 4 matrix. First row 1, 1, 1, 1. Second row 0, 2, 2, 0. Third row 0, 0, 2, 0. And fourth row minus 1, 1, 0, 3. And the Jordan canonical forms are given in the options. So option 1, 2, 3 and 4. So these are the supposed to be. So we have to find out the Jordan canonical form of this matrix. Right. Now let's now discuss the solution of the problem in detail. We first find out the characteristic equation of the given matrix, and from there we find the eigenvalues of the matrix A. The characteristic equation is given by determinant of A minus lambda is equal to 0. So from the matrix A, subtract lambda I4. Then you will get this 4 by 4 matrix. So the diagonal entries are 1 minus lambda, 2 minus lambda, 2 minus lambda, 3 minus lambda. The remaining are same as in A. Right. Observe here, you have to find out the determinant 4 by 4. Observe here, the third row having only one element 2 minus lambda. That's the weak point here. So take delete third row and the third column. Delete third row and third column. Then you will get 2 minus lambda multiplied by the 3 by 3 matrix, the remaining 1 minus lambda, 1, 1, 0, 2 minus lambda, 0, minus 1, 1, 3 minus lambda. Right. Now to expand this again, look at the second row, second column. This element is 2 minus lambda. So this will be equal to 2 minus lambda into 2 minus lambda into the remainder of the determinant. That is the determinant 1 minus lambda 1 minus 1 3 minus lambda. So this implies 2 minus lambda whole square into the determinant AD minus BC, and 2 minus lambda whole square is this on multiplication. It will give you 3 minus 4 lambda plus lambda square plus 1, and this is nothing but lambda square minus 4 lambda plus 4, and that is again 2 minus lambda whole square. So in total you will get 2 minus lambda to the power of 4 is equal to 0. That is the characteristic equation. Therefore the 2 is an eigenvalue and it is repeated 4 times. Therefore the algebraic multiplicity of lambda is equal to 2 is 4. We continue the discussion. Right. Now, we find out the geometric multiplicity of lambda is equal to 2. Geometric multiplicity is nothing but the nullity of a minus 2i. The nullity of a minus 2i. So, you take a minus 2i, that means subtract 2i from a. So, it will be 1 minus 2 minus 1, 2 minus 2 0, 2 minus 2 0, 3 minus 2 1. The remaining elements are same as a. This is a minus 2i. Right. Now, we will first find its rank. To find its rank, we will reduce this matrix into the row reduced echelon form by performing elementary row operations on it. So, we perform R4 is R4 minus R1, R4 minus R1, and thereby the 4 1 elements, fourth row, first column element will become 0, and this will be get changed. So, that will be the fourth row will be 0, 1 minus 1 0, 0 minus 1 minus 1, 1 minus 1 0. So, this is the 1. This is the 1. So, we want to make it, these things. So, we make R4 is 2 times R4 plus R2. R4 is 2 times R4 plus R2, and thereby this element, that is third row first column element, will become 0. So, now it is reduced to a row reduced echelon form, and now the number of non-zero rows will give you the rank. So, the rank of a minus 2i, the number of non-zero rows in the row reduced echelon form is 2. And now we apply rank-nullity theorem for a minus 2i. Rank of a minus 2i plus nullity of a minus 2i is equal to the number of columns of a minus 2i. This is none other than the rank-nullity theorem. Rank is 2 plus nullity of a minus 2i is equal to the number of columns 4 minus the rank. Rank is 2, it is not 1, it is 2. 4 minus 2, 2. It is not 1, it is 2. I am sorry. So, now nullity of a minus 2i is 2, means the geometric multiplicity of lambda is equal to 2 is equal to 2. Agree? So, we continue in the next. So, we have the algebraic multiplicity is 4, the geometric multiplicity of lambda is equal to 2 is equal to the nullity of a minus 2i is equal to 2. Now, the Jordan canonical form of A has 2 Jordan blocks. How do you say? The geometric multiplicity of lambda is equal to 2 will give you the number of Jordan blocks and their number of Jordan blocks. So, A has 2 Jordan blocks and their sizes when added is 4. Geometric multiplicity of lambda is equal to 2, that will be the nullity of a minus 2i is equal to 2. And the geometric multiplicity will tell you the number of Jordan blocks. So, the Jordan canonical form of A has 2 Jordan blocks because the geometric multiplicity is 2, and their size add to 4. Add to 4. This is because it is a 4 by 4 matrix. So, 2 Jordan blocks must be there, and when you add their sizes, it must be 4. So, what could be the sizes? The possible sizes of the Jordan blocks are either 3 plus 1, that will make 4, or 2 plus 2. So, what is correct? That is the question. And when you decide this one, then we will write down the Jordan canonical form. So, now the minimal polynomial of A will determine the size of the largest Jordan block. The minimal polynomial of A will determine the size of the largest Jordan block. So, what you do is, we compute the powers of A minus 2i until we get the 0 matrix. So, A minus 2i is not 0, A minus 2i whole square, multiply this with that, it is not 0, and a minus 2i whole cube, when you multiply it is 0. So this is 3. So the minimal polynomial will determine that one. That means the minimal polynomial of a is x minus 2 whole cube. The minimal polynomial is x minus 2 whole cube. And that the minimal polynomial of a will determine the size of the largest Jordan block. The size of the largest Jordan block is equal to the degree of the minimal polynomial, that is 3. That is 3. So now there are 2 Jordan blocks, and the largest Jordan block, the size is 3. So what is the Jordan block sizes are 3 and 1. 3 and 1. And this implies the Jordan canonical form of A is J is equal to J size is 3, eigenvalue is 2, J3 2 plus circle J1 2, direct sum. Right. We continue in the next slide. Right. The JCF of A, JCF, Jordan canonical form of A, is J is equal to J3 2 plus circle J1 2. And let's look at and that is the matrix J3 2 0, 0 J1 2, appropriate sizes of 0 matrices. And J3 2 is what? 2 1 0, 0 2 1, 0 0 2. It is the Jordan, the block with eigenvalue 2 of size 3. And the remaining is 1 by 1, 1 by 1. So that is 2. So this is the JCF of A. And let's look at our options. And in these options, option 2 is the one what we got the answer. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of the problem from linear algebra, which is based on the Jordan canonical form. And the concept of the Jordan canonical form is very, very important. Very, very important. The questions that are coming for the CSIR NET examination, these Jordan canonical forms will help us in some way or the other to solve some of the questions also. It's a very important thing. And in a normal university, in any state university, in the course like linear algebra, the Jordan canonical form normally is not included. But unless you study an advanced linear algebra, wherein you find Jordan canonical forms. Many universities stop with the elementary linear algebra. For them, the Jordan canonical form may not be there. So, prepare for Jordan canonical form, prepare the questions on it, previous year questions also you solve, and get ready for the exam. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes. We will meet once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.